Hello everyone, and welcome to another Thursday seminar in computer engineering. We are still on the very networking centric series. This seminar series of this season is very centric around networking, as you can see. Things will change in the upcoming ones. We'll cover other computer engineering topics. But today, I'm very glad to have Benoit with us today. Benoit, you made it to the shortest abstract of all our seminar speakers. I can even read it. How can we realize the promise of autonomous driving networks and review different building from proof of concept, standardizations, and research? Thanks for being here. I don't read the long biographies of our guest speakers. Benoit has such a rich experience in industry, in networking standardization. You will learn more. You can dig up more. You can go through the drafts that he has contributed to. You can write him even an email to his new company, the Everything Ops, that it will resonate to you as the moment that you see his talk. And with that, I will be stop presenting and pass the ball to Benoit. Benoit, you can start sharing your screen. Let's see. I'm not hearing you. Let's see. Try out the sound again. Yeah,
All right,
unmute.
so I'm now unmuted and you should
Yes.
hear me, and I will start presenting. Good morning, good afternoon, and thank you for the nice intro. So I'm Benoit, and I will have in this presentation a series of pointers about network management, or call it SDN, or call it ops, or call it closed loop. A series of pointers in how to do closed loop in networks. This is a discussion, this is a set of slides that I've been presenting in the IEEE workshop on WIN, intent-based networking, workshop on intent-based networking. Since that time in June, where I met Christian and where we connected, and we had so much in common that we want to keep working together. So since that time, I changed affiliation. So this is somehow the slide deck that I had, but I removed a couple of things because I'm not with Huawei any longer. So from my bio, the only thing that is interesting, this is I have a passion for correct network management. I know it's outdated to go that way, but all the building blocks that helps a network to be managed for closed loop, which is what we want to do, for what's called autonomous driving networks. I don't like this term because it makes me feel like, I'm working with Tesla or cars. But however, the comparison is about right. Why can we have autonomous cars and not autonomous networks? So these days, I have my consulting company where I help people with mentoring, standards, IETF, all the building blocks from an architecture point of view for ADN and all this. And there are some more pointers in there. And that's exactly what I plan to do here, is to give you pointers. And behind any of those pointers, it could be like hours of interesting readings or developments on prototypes. Now, networks. Did you notice that we always blame the networks for everything which is broken? And actually, it's not always a network. It might be an app which has got a bug. It might be the network itself. It might be a server running out of memory. It might be whatever, but we always blame the network. So there is a new definition of network. This is like from your home with the Wi-Fi to your PC, to the operator, to the data center, to the server, to the application. I mean, whenever Facebook is down, all the operators receiving calls telling the internet is broken. Now, the issue is that it takes too much OPEX to compare to the CAPEX. It costs too much to manage network compared to buying the network. And there are many reasons for that. It's multi-vendor, there are old devices, new devices, different domains, different capabilities. Sometimes it's just like the way that operators are structured. But the automation is compulsory. We know this. With the frequency of changes these days, with the size of networks these days, if a feature cannot be automated, it does not exist. So the complexity that we've been loving, I'm a CCIE, right? Cisco Certified Internet Expert. It has been fun to just go on networks and configure with a CLI, but it was 25 years ago. These days, the complexity we've been adding, and I'm guilty as well for that, is on the verge of turning against us. Now, you want to know this figure from TMF, which gives you the different levels of ADN, Autonomous Driving Network. 0, you configure with a CLI, what I mentioned like 25 years ago. In layer 1, level 1, tool assistance. You've got a GUI. Level 2, it starts to be interesting because you have APIs to program your network. That's where we want to go. In level 3, you declare an intent, and for that intent, you will have a little bit of automation to try to fulfill that intent. When we reach L4, you see the humans assist the machine while it was the reverse before. And we're hoping to get real, like intent-based machine decisions. We're not there yet, and we'll go to complete autonomy, like the autonomous cars. Now, I could go in the different definitions of the network because I mentioned networks. It could be like what? Me at home as a consumer. At which level am I? Maybe 1 out of 5, maybe 2. There is also an enterprise network, but all enterprises are different. There is the service provider. There is data center. There is cloud. So depending on where you are at different levels of autonomy. The most complex being the network operator, the service providers with multi-vendor, all new devices, silo organization, different domains, different responsibility, and all this. Now, what do we need? And this is the goal of this presentation, to give you pointers on what we need to solve ADN. And we need to review some of them. We need to have data model driven management. We need to have service assurance. We need to have digital map. We need to have network specific rules. We need to have actionable symptoms. Because for the level 3, we must have automation, intent, and some closed loop. And it sounds like obvious, but without an intent, we don't know what we have to correct. But trying to find an intent, trying to define an intent is not easy. Is this connectivity? Maybe. You had a course maybe a couple of sessions ago about latency. Is the intent to have a low latency? Maybe. So how to formalize this so that the machine could act on it? Not that simple. So maybe surely you know the Maslow pyramid of needs, right? With physiological needs, then safety needs, social belonging, self-esteem, etc., etc. I'm trying to have the same analogy with what we need to go to autonomous driving network. And the first thing is I need to have configuration with a data model. Maybe you heard about Yang. Yang is a data model that works with NetConf, RESTCONF, gNMI as protocols. It's a schema, it's a data language, it's a data model. And when I see a Yang module, because a Yang module can generate an API, I actually see Yang as an API, which means that if you know about Yang, if you want to know more, I connect to a router. I could directly download all the YANG modules. So it's kind of a contract on what I could be doing with that router. And from there, I generate the API automatically, and I could act on the router. That's for config. This next one, this is telemetry. Why? Actually, if you configure from the controller with YANG based, so schema based with NetConf, RESTCONF, right? At some point in time, if you want to do closed loop, right, you want to receive telemetry information from the network. If you know about networking, there is syslog, there is flow record with NetFlow IPIFX, there is active probing with OWAM, TWAM, there is like IOAM, I won't go in all the details, there is MIPS, there is CLI. But if the model for config is in YANG, well, it's obvious that the telemetry must be YANG so that we're able to compare the schema together, right? Something which is very, very costly in the industry is to map a schema that you use for configuration with another schema that you use for monitoring. Think about API versus CLI. Is it the same semantic? Do I have to script the CLI with expect to retrieve the information and see that what I configure is about right? So model-driven telemetry. And for this, we're dealing with IETF YANG push. IETF YANG push telemetry example. I'm involved in the IETF as a co-chair for 2 working groups. And in one of them, we define this architecture where we have a router is sending telemetry with YANG push to a collector. And actually, we're going to send information via Kafka to a database while keeping the semantic, right? So from here, we need to ingest the schema coming from the router, for that specific router. We need to encode the semantic into up to the time series database. And this sounds like easy, right? But this is like the example here. If I have temperature in my database, what is this? Celsius? Kelvin? Is this like an average? Is this like instantaneous? So all the semantic that you need for the analytics here is key. If you don't have that, you're doomed. Because if you try to apply your intent, and the intent is temperature, and you don't have the right semantic for temperature, your closed loop is broken. And by the way, you must know about the data mesh principles. Okay, I will skip that. It's one of your homework, understand the data mesh. But if you deal with data, that's the way you have to do it. Domain-driven ownership of data and data as a product. That's all I'm going to tell you for now, but keep that in mind. If we look into this architecture in a more detail, and by the way, I always try to put the links there, you will see that we have the YANG push here, the YANG push subscription. Then we need to discover the capabilities from the node. Then we send number 3, the YANG push. Then need to discover a schema with an arrow coming from the collector to the router. Why? Because we were defining UDP-based telemetry. If we take the analogy of flow records with NetFlow and IPIFX, this is the way to push a lot of telemetry. But it means that the collector has to get the contracts from the router telling, oh, which YANG module do you support? You're sending me something, this temperature, get me the exact schema for that. And then we send the schema to the YANG schema registry, and we send it over a message broker, Kafka, to the data storage. And these are all the different drafts that we're working on. And also IETF Hackathon. Because what we have done is that's basically the IETF 123 from Madrid last summer, where we define an MVP 1 for YANG push, an MVP 2, an MVP 3. And this is the team with people from different vendors, universities, operators. And this is how we test the interoperability of this. And if you look at the implementation of all of these, this is actually a great way to start to be involved in the IETF with data collection. I assert that data collection has been done the wrong way so far, at least not in a way that we could be solving the ADN because we're missing the semantic. Now, Yang push is only one part of it. This is what we call the management plane, right? Getting information about the counters, the QoS. But there is also the forwarding plane, knowing where the packets are going through the network. And the control planes where the packets are supposed to go. And now if you compare all of these, this is also, it's actually an even bigger team where we say Yang push management plane. Oh, I look at my quality of service counters. The IPIFX, where I see exactly where the packets of the customer are going through, with segment routing v6, with delay, with IPv4, IPv6, you name it. And BMP, this is the BGP monitoring protocol. And this is where we target, where we say to the network, this is how I want you to forward the traffic. And then you start to see that the correlation of all these trees are going to give you some anomalies. And that's where we could start troubleshooting a network in an automatic way. All right. I hope the pace is about right. There's a lot of knowledge behind all of these. But now let's assume that you have a network. Data model driven management with config and telemetry, with Yang for the management plane, with IPIFX and BMP for the different planes, because not everything is in Yang. Now let's start with the closed loop. The closed loop, we want to do number 5, a reduce mean time to detect, mean time to repair. And I believe into component and feature assurance. And then we could go to service assurance. Like, I want this video call to be fine with packet loss, delay, and jitter. So for the service assurance, we developed, again in the IETF with those 2 RFCs, we developed like what's called service assurance for intent-based networking. Because if I look at the challenge, and we've been working on this for many years, but the challenge is that AI and ML is everywhere. But AI and ML without the intent is useless. I could expand on this. It will be for later session. But then how do we determine the intent, right? And how do we map the intent to a service and all the collected metrics? If I collect the interface counters or the interface errors, how do I know which services are impacted? And that's what we build with those 2 RFCs, with those POCs, and it's also in some products. The value is that whenever a service degrades, and not the top service there, I could see directly where the faults are, or at least I could see where the problems are not, which is helping a lot in case of troubleshooting. And now if I click on this one, where it is, I think this one is a VPN data plane issue. I could see, because it's a graph in both directions, from the service to the bottom and to the bottom to all services, I could be looking at all the different services that are impacted. And that gives me a great way to troubleshoot my network. If I see that all my gold customers are impacted, I know exactly that I have to focus on that specific component and its assurance. And this is the first thing I have to do. And again, coming from TMF, I mentioned that I believe into if I go back to a couple of slides, I believe into this component feature assurance and service assurance. Then this is exactly this picture, because it means that I could be doing a closed loop at the resource level. I could be doing a closed loop at a service level. I'm going to reroute some traffic to make sure that the SLA, the service level agreement, are respected. Or I could be doing also a closed loop higher in the business closed loop. And this is how we're going to solve ADN. Now, let's speak about anomaly detection. So we've been collecting information from the three different planes: management planes, data plane, control plane. And again, in this working group called NMOP, we've been working on semantic metadata annotation for network anomaly detection. So there is a lack of good AI and ML engineers in the world. And there is a lack of good networking engineers in the world. And there is a lack of good software engineers in the world. And what we need in network operation, this is the combination of the best networking engineer with the best software engineer with the best AI and ML. Guess what? It doesn't exist. You can be an expert in one of those fields. So it means that we will have to exchange information, annotated incident. And we're going to exchange this between what? The operators and the vendors. Vendors have a problem with your router. This is all information I have for you. Troubleshoot it. But also between operators and maybe with university. Why? We have a couple of AI and ML guys per operators. Okay, you can define a couple. But most of the people are researching on the same algorithms, the same type of algorithm. Can we do better than this? Can we exchange the annotated information? And that's what we did, right? There is the semantic metadata annotation, and there's another draft, which is network anomaly lifecycle. Because we could detect problems based on the symptoms. We could validate that these are real problems, and sometimes they're false positive. And then we could go into refinement. And if you take this draft, which is here at the bottom, again in the NMOP working group, along with the annotated information, which are, by the way, like this. I have a problem here in my network, in my time series of data, and I see some relevant states. I see it's changing, right? This is a state here. I see that there is an anomaly. Okay, give me the version, the state description, start time, end time. Confidence score. Well, sometimes you're not sure. Maybe I'm 50% sure. And some annotation there. And guess what? It could be done by a human. A human troubleshooted this. So he's actually very sure there's a problem. Or it could be an algorithm, an AI or ML algorithm, right? And in total, it gives me a concern score. And these are the services that are impacted. So this is information that we want to share whenever there are incidents. Now, I skipped the AI and ML part. It's obviously important, but it should be covered in a different session, right? But this is where this algorithm there, if I go back to the previous slide, I could be telling, you know what? If I take my tools, I have algorithm version 3 and I discover your problem in 30 seconds. And if I come in here and we're going to exchange exchange information with operators, vendors. Maybe someone else will have a better algorithm that's going to detect it in 3 seconds or with a higher level of confidence. So this starts to be an ecosystem of sharing information, incident, creating the AI and ML tools. And there is this project which started again in the IETF hackathon on having, this is called Antagonist. That's a development of a backend and front end to enable network experts to provide labeled. When I mention annotated, right, AI and ML persons are talking about labeled data. And that's a way to label the data and to tell that's what I see as problem. And sometimes it's even useful within an operator because, as I said, we always blame the network, but sometimes it's not. So we could be pushing all information we know to a different domain. Like, okay, that's what I see from a networking point of view. Now I want you to look in the servers, in the cloud, because maybe it comes from there. Now, what else? Another building block. That's a digital map. Question to you, what is the source of truth in network? Well, it depends. It could be your inventory system. It could be what's deployed and working in the network. It could be your IP address management system. But what links everything together? This is what we call a digital map. And this digital map is, by the way, called CMAP in the IETF. It's a core multi-layer topology model. Multi-layer because you want to have like layer 1, layer 2, layer 3, service, users, etc. So it's the core topology entities, their work, their role, and the core properties. This digital map is the basis and the prerequisite for something which is mentioned many times these days. This is a digital twin, where ideally I want to have a second network, which is a emulation of the first one. And then I could play and simulate the new services I want to have in there. So what are the use cases for the digital map? You know it? I mean, let me say this. Operators, sometimes the first one is network inventory. It seems very simple, but there are devices that are pre-staging, pre-provision, and all this. So the inventory of what is in network is important. So risk placement, intent assurance, etc., capacity planning, but the ultimate one is digital twin for what-if simulation. And the requirements from operators. So first homework for you. Review this draft. There's a link where we describe the use case and the requirements for digital map. Send this to me and to Christian in CC and tell me what you think, what is right, what is wrong, what could be improved, etc. Something else here. This digital map, we did a POC in the hackathon. And that's an example here. We would see, I've got, for example, here, ISIS. And that's a view of ISIS. I've got on top of that SRv6. I could have on top of that the service. Remember? Service is important. Some operators are telling, I have so many issues in my network that I'm going to focus only or firstly on the ones that are impacting my customers. So that's why having the view of the service and the intent of the service is the first thing you have to do. And then you need to decompose it into the digital map, you need to correct the information, etc., etc. Now, what I have here is the intent assurance graph. It comes from the controller or the orchestrator, because we take as input what we want to configure. So that's a view of what we want. Now, the digital map, one way to do it is to take the input from the network, what you have in the network. And sometimes you might be having an intent conflict. Remember, without the intent, you cannot do closed loop. Here, I've got two views already, the one from the controller and the one from the network. And I could have discrepancies because this is the intended and apply status. Because I've got two network management systems and they're sending conflicting information. Because someone just changed the CLI in a router directly. And that means that the controller doesn't know about that. He has to sync to the network, etc., etc. Oh, this one, specific intent. I've got the backup link. It's a very simple use case, but how do you know it's a backup link? Well, you need to formally mention it's a backup link so that you will check your intent, so that you will check that the backup is always up. Because if the backup is down, well, your intent is not respected. Okay, maybe your customer is not affected yet, but if the primary link fails, you're doomed. So I mentioned the IETF working group, right? NMOP, Network Management Operations. So that's a place where we deal with NetConf and Yang integration with Apache Kafka and time series database. Remember the temperature example in a time series database with which I want to have the semantic. We deal also with the anomaly detection and incident management. Remember the life cycle. Remember annotating information. Issues related to the deployment and usage of Yang topology, what I call digital map or CMAP. That's also what we do. And we're going to do this topology in Yang. Right, remember? The schema for configuration, the schema for telemetry, and now the schema for topology. And by the way, this SANE is this one, service assurance, is also a Yang module, so it's also an API. If there is no API, it doesn't exist. If I cannot automate it, it doesn't exist. And okay, this one is about operator requirements. Now, why I connected with Christian and why we clicked, it's because you are students, you are university. I'm one of the co-chair of this working group. I would like to know if you're interested to participate. And participate in the IETF means sometimes simply a simple thing as reviewing a document, like your first assignment. It might be joining the hackathon and trying to hack to implement one of those IETF drafts, right? And it's also to be aware of the latest developments. And I've got an assignment number 2. Now, if you care about networking, if you care about actually any topic, what you want to catch, these are the market transition. And I have a draft here, which is a brand new draft. And I put the link there at the bottom. It says Yang message keys for message broker integration. It's the version 00 that we posted like a couple of weeks ago. I would like you to review it. There is a technical aspect and there is a business aspect to it. I would like you to drop me a message and CC Christian on why this draft is going to be pretty important in the future. It's not yet well explained there. I will be having shortly a blog about it. Shortly means maybe a couple of weeks, right? And I would like you to try to look at this business value and why it's going to be important. And why maybe if you want to join NMOP, you might want to review it, play with it, etc., etc. The last topic I want to mention is that knowledge graph. Knowledge graph for network operations. So that's this document is also one that you would like to review, and there are many operators in there: Swisscom, Deutsche Telekom, Bell Canada, NTT, Telefonica, right? It highlights a couple of problems we have in operations right now, and why a knowledge graph with something like RDF might be a way to link the information. I'm sure you heard about LLMs, obviously, right? LLMs is going to solve the world hunger. Well, guess what? Not for networking, unless we have clean data, we have consistent data, we have interconnected data, which is the point behind the knowledge graph. You want to connect information. For example, I mentioned 3 planes: data plane, management plane, control plane. And we want to interconnect this information with clear semantics and the context. The context, if you know about networking, I've got a router. Is this a customer edge router? Is this a provider edge router? Is this a provider router? They have different roles, different contexts, so you're going to troubleshoot them differently. And that's my ex-colleague Michael Mackey, right? And it's on this thing here, he's doing like a cooperation with Swisscom, and explain what I was focusing on in my previous job on the knowledge engine, where you want to collect information from the network configuration, the network models, remember the contract between the router and the controller, service assurance, digital map, and connect everything together to, at the runtime, try to find anomalies with AI and have a better way and faster way to troubleshoot network and have something fundamental to as a basis for ADN. And this is somehow my last slide, and I've been maybe rushing a little bit, but giving you a lot of pointers in all directions. So if you're interested to solve the ADN, Autonomous Driving Network, and the closed loop, you must have router with schema, with YANG for management plane, with IPIFX for data plane, with BMP for control plane. You must have the APIs that are coming from YANG. You must be having the configuration and the telemetry. You must be having a digital map. You must be having the service with its intent. You must be having the analytics that are based on top of a time series database, in which we have the clear semantic linked to a schema, remember temperature. And then we might be thinking about the digital twin, which is a copy of the real network for what if scenarios. What I want to say is that there is no silver bullet. It's like the Maslow pyramid of needs. You need to have small building blocks, and they're going to build on top of each other. So it's a journey. And we look at some of those building blocks, but that's exactly the interesting part. We take all these building blocks together with data collection, etc., etc. So my point is that let's continue researching and prototyping and standardizing. And then in the end, we're going to have maybe resolve and realize the autonomous driving network vision. And with this, I would welcome any questions if you have.
Great. Thank you. Thank you so much. Virtual labs. And thanks for not only all the pointers that you have provided, but also the additional context that you have shared about how we met, how we connected, how we had some clicks, and how we have some common visions of engaging the next generation of students from undergrad to masters to PhDs, doing research the way the industry requires, contributing to standardization, to the actual realizations. This is goes directly into the heart of the Smartness Engineering Research Center, where we seek this type of talent building. Okay, so
Exactly.
thanks. Let me see if there are questions over the chat in YouTube. No, but we've had over 10 people. Nice, that's great. Let me, if you can stop sharing your screen, I will share with you my screen with selected questions from our students, and I will share the full spreadsheet with you. Uh, it's interesting because they have to come up with the 5 pieces of work that they would read if they were preparing for an interview with you. It's always fun for our guest speakers to see how our students prepare themselves. But let me go down and I've selected here some of them. So, given the progress in standards, you mentioned IETF, the ETSI, the TMF forum, open. So, if you had to pick one bottleneck, try to think that is preventing the practical realization or moving forward. Is it more on the standardization side? Is it more on the implementation? Is it more on the business side? Or some, like you mentioned, this unifying framework, knowledge framework? If you had to blame or remove some roadblock, which one would it be?
All right. First of all, this question is interesting because it covers many things.
Mhm.
And I suspect that someone who wrote that question knows a lot about the industry. It might not even be a student. But okay, this is my private bet. It mentioned telemetry. It mentioned IETF. It mentioned ETSI. It mentioned intent translation. It mentioned semantic, closed loop, etc., etc., knowledge graph. Now, to answer your question, we need to address all of these. And to answer your question about what is the biggest bottleneck, I would have maybe a provocative answer. You start to know me by now to make people react. And I would say that the biggest bottleneck is not specifically technical. Now, let's take a comparison. If I take a Tesla, whether you like it or not, Elon Musk said, I'm building a new car. If you want to invest in my car, these are the APIs. This is how you communicate with me. If you take an existing car company, there are about 200 manufacturers for Ford, for example. And as a consequence, you need to have schema translation, trying to integrate, etc. So the biggest bottleneck to do closed loop is the integration of all different components. It would be a piece of cake to restart a full network design, a full network with brand new components, and to do closed loop. Okay, piece of cake, I slightly exaggerate, right? But if I take operators right now, there is a mix of legacy devices, new devices, different vendors, different domain, even silo organization that don't speak to each other. The server guys don't speak with the networking guys, and all of these. So the biggest bottleneck I would say is not specifically technical. Technically, I believe that we kind of know what we are doing, but the issue with innovation network management is that it takes time, right? You cannot just throw away the entire network and start from scratch. That's maybe my answer. I could give you a technical answer, but let me stick to that one for now.
I think that's the organizational barriers. They're humans are very often right, and it's a tricky one. That one I would not tag as ChatGPT. I know many of our students and our colleagues use ChatGPT, and I can parse from the questions that some of them were from AI. So, but that one didn't look like. I will double check who was this. How do you say? Yeah, the convergence, right? I think that's a good one. Let me pick this one because it's right on spot. And we were discussing this a little bit. We are seeing LLMs taking over many automation aspects, the agentic internet. How do you see this IETF standardization with the all this more generative AI and AI machine learning world converging? Uh, can you share some thoughts or vision? Do you see them
Right.
being explored in IETF? And what's your take on that one?
So I've been telling to all the vendors being the router vendors, that there are things that are not worth fighting about, right? The telemetry is one of them, meaning we should standardize telemetry as far as possible because it's not where the money is. So we should be able to collect information the same way. And I would go to the point to say that data collection will be free in the future. Free, I mean that uh, people will not pay a product to collect data. You can go to any potential operators, enterprise customers, all of them, they have a data lake already, some sort of collection data, right? What we need, I mean, is that they're going to build their own collection data with the architecture I was showing in the past. And then on top of that, this is where the real money is, with the machine learning, the AI, the convergence, and all this. So we have to move as far as possible to the analytics part, right? And this is where we will have rapid development. This is, for example, where I was mentioning that we need to exchange the labeled data with each other. And then we're going to say, oh, this algorithm is finding me the information with a higher level of confidence. So I believe that we're going to see, if you look at the hyperscaler, everything is code, right? So we need to move to a model like this, where it's continuous integration, CI/CD. And this is how we're going to solve the issues, and not with building block network management systems. So we need to apply IETF, what it's good at, standards, and the more like open source development, CI/CD, that is constantly changing on top of that. Not sure if I answer correctly the question. Feel free.
It's it's a hard one. It's almost a visionary. For sure, it will impact, right? All these AI tools. Uh, I don't have a clear opinion. I'm sure it will impact, but not sure how and how best and when and where to stop and where to put the human back in the loop and 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 let me talk about humans. I was getting this live question. This is a live questions from Rafael Pasquini, is a professor also active in smartness, and he brought this again, not an easy one question. Okay, let me try to read it to you. So uh, how you see the possibility of multiple organizations, stakeholders, sharing information through APIs and third party getting some information, of course, for the apps, for their own uh, um, good goals. Uh, but then the possibility of inferring actual situations, uh, estimating SLA violations that today as a black box are not possible. Do you see, in other words, do you see the vision of application developers and infrastructure providers getting closer throughout the development of standards and automation that you are mentioning, or this will be still silos, or the APIs will be so much high level that may not get to all that way of application and network integration from applications that come from third parties. Okay, that's my own interpretation of this point. How do you see this?
So multiple answer to that. Uh, in the past, we tried an effort which was called inter-provider QoS, right? So for example, I'm in Belgium, you're in Brazil. Let's pretend you're a bank, I'm a bank, and we have branch offices. And we must have this call. So I need to go via my local provider, I need to go maybe over NTT, I need to go into your local provider to have connectivity. That effort was there to be able to exchange the QoS information between different providers so that the end user would have the right information. And somehow it did not take off, because if you are the provider in the middle, do you want to share your SLA violation with your neighbors? And actually the transit provider might be, or the local provider might be comparing the transit provider, right? So there is like, we could be sharing, but for what goal? And will the data be used in a way against you? That's the first thing I want to say. Now for configuration, it would be ideal if me as a bank trying to connect to you, I could go to a provider and say, give me your API. I want to configure my layer 3 VPN to you. We all want that. Now this is very complex, right? Because the operators need to access a northbound interface of the controller of the operator to do it. So I'm not sure this is going to happen soon. There is something that we start to see, is that whenever we'll add automation, how do we solve the issue of the multiple intent? You have your intent, I've got my intent, and we want an intent from the person on which you've got the API, and conflicting intent will have to be resolved. And those multiple intents, without the digital twin to check what we could be doing, is not easy. So you see, there are a couple of prerequisites to do that. However, in certain cases, it works fine. If I want to have from, my service providers, or, my domain, I could want to have extra memory or extra gigabits, or whatever. This is possible,
Mhm.
right? So we might be seeing this in the future, but think about the pyramid of all the things we need before that.
Yeah.
There is one thing which is trying to be pushed in the IETF right now. This is a telco cloud. So the cloud telling to the network what they need, or vice versa. Let's say that tomorrow we organize a big event in Brazil. There are 10,000 people. I need to have some extra capacity. So at least if a provider has got at the same time network and the cloud, can we have APIs to configure and monitor? So in limited domain for now.
Hmm. Yes, I like your answer. Precisely the same point was what colleagues in Shista, friends in Shista, were mentioning about the resolution of conflicts of intents. It's a hard one to tackle, and Yeah, that makes makes sense. Talking again, or getting back to humans into the loop and balancing them into this. Um, can you shed a little bit light on the balance of automation and humans moving up into the design, or keeping them, or it will depend on the use case? Uh, how especially critical network scenarios, right? But how do you see
Very
this
good. So I would say it depends on the domain, right?
Mhm.
If we want to do automation, I mean, I've seen systems where we optimize the Wi-Fi. Okay, great, we have to do that. But it means that I could be playing with small parameters and a kind of reinforcement learning, see if it works. Because it's not really interrupted. Or if it's interrupted, it's for tiny piece of time. And
Mhm.
this one is fine. Now, if we speak about I sometimes see researchers telling I do kind of reinforcement learning in real life networks, not Wi-Fi. And I'm thinking, sorry, but you're dreaming, right? You cannot play with an operator network and say, oh, let me switch that one or that one and maybe see if it works. And then people will say, oh, it works or it doesn't work, like a thumbs up, thumbs down. No, 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 it doesn't work that way. So the human will still be involved for a bit of time, at least to validate what the action is. And whenever we could say, in all circumstances, similar to this, apply the same one, the same action, because it was exactly what I did 5 times before, then this is possible. So this is a little bit my my answer to that. What I would like to see and what I start to see is that each time a human sees and create a postmortem and discovers something, it's not too difficult to encode what the human did and the flow he followed. And the flow he follows is actually what? A knowledge graph.
Right. Hmm. Yeah, yeah, yeah. I think, and then you're taking a good step towards my last comment, question, closing um, thought. It's a next step, right? So you were talking about a flow. It's a sequence of steps. We are seeing the chat GPT, all these tools doing this reasoning, right? So that you can follow up when they get until the answer, and then whether a human can verify whether there was some mistake or something to improve in this flow. And what I also liked and would like to close our very nice seminar talk today is about the digital map. I see many of us researchers and colleagues going all the way. Hey, network digital twin. I'm doing a network digital twin, but actually, what we have done in many cases is has been, and the way we named it many years ago before the topic came, it was a network mirror. It was just a digital version. The twin, it's much more, it's deeper. And I want to close with this concept of the digital map used for modeling, as you presented, and ultimately being able to deliver digital twin type of use case scenarios and assist in the closed loops before taking decisions, before assessing decisions, whether this makes sense. And with the homework review of having a look into this IETF, send us an email. Also, it's a good plug because we are opening right now the season for applications for masters and PhD students to join our faculty in the first semester. So they are open, they just opened yesterday and they will be open until the end of October. So what better for an application letter than, hey, I saw your seminar and I did the homework and here it is. Would you like to have me as an advisor, as a master's and PhD, and get a scholarship and get the work done with you and in collaboration with folks like Benoit.
Pretty
I
good.
think
This is what we discussed already like a couple of months ago, right? That we want to get motivated students, and all topics that we've been mentioning here. There are many works there, and I hope that I share my passion for this, because at some point in time it was like networking is boring. No. Networking is actually very, very interesting. It touches many different aspects.
I think that the passion bit is excellent for us to close because you really pass this passion, and our students are passionate about their starting classes at 2 p.m. Brazil time. Many of them they are starting, maybe they are late, they are running with their mobile phones. Thank you again, and stay tuned next week, another seminar. Benoit, thank you so much. Keep in touch, keep safe.
Thank you. Bye bye, everybody.